You know, right beneath the surface of our everyday lives lies the ultimate control center of the entire human body. Welcome to today's Explainer, where we're going to unpack the absolute marvel that is the architecture of your own mind. We'll be turning some really complex microscopic biology into a journey that just makes sense.
Think about this for a second. At just 1.4 kilograms, that's roughly 3 pounds, this tiny, kind of soft mass sitting right there inside your skull, it controls absolutely everything you do. Seriously, every single thought you have, every memory you cherish, every complex emotion, and literally every movement you make stems from this one control center. It is the ultimate supercomputer. But how does it actually work?
Well, to really get it, we've got to look at the sheer massive scale of its internal components. Contained within that incredibly small mass is a staggering number. Ready? 86 billion. Yup, 86 billion individual neurons, and they are operating inside your head right this very second. I mean, if you could somehow listen in on this microscopic network, you wouldn't hear silence. No way. You'd hear this constant electric hum of 86 billion wires just firing, communicating, and interacting in real time.
Section 1. The language of neurons, sending messages.
So all this communication happens in this insanely precise, lightning-fast sequence. Step 1 is the electrical impulse. Imagine a sharp zap of electricity traveling down the neuron. But here's the catch. Neurons don't actually physically touch each other. So for step 2, that signal has to jump across this tiny, microscopic gap called a synapse. And how on earth does it make that leap? Well, that brings us to step 3, chemical neurotransmitters. Basically, the electrical signal smoothly transitions into a chemical signal to cross that gap, kind of like a rapid whoosh, carrying the message right to the next neuron. Zap, jump, whoosh. And this is happening millions of times a second.
Section 2. Making and keeping memories, storing connections.
Okay, so those tiny, rapid-fire electrical and chemical signals we just talked about, they don't just vanish into thin air after they fire. Actually, they build the very foundation of our memories. But, there's a pretty clear dividing line between short-term memory and long-term memory. Think of short-term memory like a temporary sticky note. It just holds a few pieces of info, maybe a phone number, just long enough for you to actually use it. Long-term memory, on the other hand, is your permanent storage. When a memory transitions from short to long-term, it literally gets physically wired and locked right into your brain's architecture.
The absolutely crucial takeaway here is that practice physically strengthens those connections between neurons. Whenever you repeat an action, whether you're, playing the guitar, learning a new language, or just studying for a test, you are firing the exact same sequence of neurons over and over again. And here's the cool part. The more they fire together, the stronger and thicker that specific neural pathway becomes. It's literally the microscopic mechanical basis for all human learning. Practice really does make perfect, or at least perfectly wired.
Section 3. Processing our complex emotions, survival, and feelings.
Right, so we've talked about data, memory, and learning. But how did these exact same physical networks translate into how we actually feel every single day? Well, it all boils down to our core emotions: happiness, fear, anger, and sadness. When you process these emotions, kind of think of your brain acting like a conductor, keeping time with your internal rhythm. If you encounter fear or anger, that biological rhythm dynamically speeds up, right? It sends this huge cascade of specific neurotransmitters through your brain, totally preparing your body to fight or flee. But if you experience happiness or sadness, that rhythm shifts entirely. So these emotions aren't just abstract, fuzzy concepts. They are very real physical and chemical states happening right there in your mind. Now, what's really interesting about this is the specific hardware responsible for that alarm system. It's called the amygdala. As you'll see from its core function, the amygdala is a brain region absolutely crucial for processing emotions and ultimately ensuring your survival. It is constantly, and I mean constantly, scanning your environment. It processes those feelings of fear or anger almost instantly to keep you alive and safe, usually way before your conscious mind even realizes what's going on.
Section 4. The purpose of sleep, restoring the mind.
So after all that intense processing, the alarm bells going off, the memory building, and 86 billion neurons humming away, the system desperately needs a break. But sleep is not just about powering down. It's actually a highly active maintenance cycle, and we can break it down into 3 main functions. First up, for memory, we have consolidation. This is where the brain basically replays the day's events, taking all those short-term sticky notes we talked about and locking them into long-term storage. Next is the body, which focuses on health and restoration, literally clearing out cellular waste. And finally, the mind engages in dreaming, which turns out to be a vital process for emotional regulation. It's just this beautifully choreographed biological sequence that repairs your 1.4 kilograms of hardware every single night.
Section 5. Mind-blowing brain facts, discoveries and truths. Okay, now that we understand the structure, the language, and the maintenance of the brain, I want you to consider this. Did you know the brain feels absolutely no pain directly? Seriously, it's true. Despite being the exact organ that processes every single pain signal, from a stubbed toe to a burnt finger, the brain tissue itself completely lacks pain receptors. A surgeon can literally operate on the brain of a fully conscious patient and they wouldn't feel a thing in the brain itself. Crazy, right?
And think about its power requirements for a second. Despite being only 1.4 kilograms, which is just a tiny, tiny fraction of your overall body weight, the brain consumes a massive 20% of your body's energy. That's a full fifth. 1/5 of all the oxygen you breathe and the calories you eat goes directly to fueling those 86 billion electrical impulses. So yeah, it is a remarkably power-hungry supercomputer for sure.
But honestly, perhaps the most reassuring fact is this. The brain can adapt and change throughout your entire life. Your mind isn't just some static, unchangeable block. Thanks to a really amazing property called neuroplasticity, your brain is incredibly structurally adaptable. It really doesn't matter what your age is. Every single time you learn a new skill, form a new habit, or overcome a tough challenge, you are literally rewiring your brain's architecture.
Which brings us to a really powerful final thought I want to leave you with today. The human brain is the most complex object we know of in the universe, and scientists are still discovering new things about it every year. Just think about that. It sits right there behind your eyes, an entire universe of 86 billion connections, constantly shaping exactly who you are. So I'll leave you with this question. Knowing that your brain physically alters its structure based on what you practice and learn, what new pathways are you going to build today?